The valence electrons in the outermost energy level of an atom are responsible for the electron activity that occurs to form chemical bonds. A Lewis structure is just a representation of an atom that shows its valence electrons. The number of dots that are placed around the symbol equal the number of s and p electrons in the outermost energy level, or the valence electrons. Paired dots represent paired electrons, and unpaired dots represent unpaired electrons. So let's take a look at nitrogen. And we see the electron configuration of nitrogen is 1s2, 2s2, 2p3. So the valence level is energy level 2, and it has 2 electrons in the s sublevel and 3 electrons in the p sublevel for a total of 5 valence electrons. So the 5 valence electrons we will draw as dots around the nitrogen. So to draw those dots, we'll draw the first 2. They come from the s sublevel, so we put the first 2 together paired. And then the other 3 would be drawn unpaired. Remember Hund's rule, which says that if you have 3 equal orbitals, for example in the p's, that each electron will go into an empty orbital before it pairs up. So nitrogen would have 5 valence electrons, and it would have 2 paired and 3 unpaired. Well, now let's take a look at bromine. So if we look at bromine's valence electrons are also in the second shell. We have 1s2, 2s2, 2p5. So here's the valence electrons, and we have a total of 2 electrons in the s sublevel and 5 electrons in the p sublevel. So when we were drawing the dots, we would want to draw 7 dots around the symbol. So let's try to draw those. So we draw 2 that are first paired. They're around that's from the 2s2. Then we draw 1, 2, 3, 4, 5, 6, 7. So bromine has 3 paired electrons and 1 unpaired electron. So by now you're getting the idea. This is not really complicated, and something that can make it even less complicated is to remember that an easy way to figure out how many valence electrons an atom would have would be based on its group number. So let's look, for example, phosphorus. If you look, it's in group 5A, and it has 5 valence electrons. 1s2, 2s2, 2p6, 3s2, 3p3. So the valence electrons are right here in the third level, and 2 and 3 are both its valence electrons. So we need to draw 5 valence electrons around the phosphorus. So the first 2 are going to be paired. Those are both in the s orbital, and then we go 3, 4, 5. Remember Hund's rule that says the electrons will go into empty orbitals. Now what's really interesting and worth noting here, so nitrogen is in the same group as the phosphorus. And if you notice, nitrogen is also in group 5A. So one of the reasons that the periodic table, because of how it's organized, elements in the same group will have a similar chemical properties because if they have the same number of valence electrons. So they tend to bond in similar manners.